looks good. So, hi everybody. Also, welcome from my side. Thanks for having me. Before, maybe you saw on the picture with the city, there on their side there was a small Helm logo on the previous talk, and now here in big. So today I want to show you how Helm works, make with you a small demo, look at all steps, and then going a little bit into how to enhance the experience with also helmfile and other tools that you can use around for it. If you have questions, you can also do it during the task if they are related, or at the end, how you want. So, a couple words about me. I work since over 6 years with Kubernetes, with Helm and helmfile a little bit less, but used it in many products and many projects over many years, also production in different configuration. Just because we are on CNCF, I also am a cloud events maintainer on the SDK for Rust, but not really active there, because mostly I'm just working as an architect in cloud and enterprise environments. So, just really short to recap what's Kubernetes, right? Because Helm doesn't work or has no sense without Kubernetes. Kubernetes is an open source container orchestration tool maintained by the CNCF, as mentioned before, and it has a concept of desired state, right? So you always apply resources, the Kubernetes manifest, on to the cluster and say, hey, that's the desired state I want to, and he looks then, the cluster, that he can apply these things to your desired state. So for example, you say, I want a deployment with 2 replicas, and then you just push it to them, and he has to look, okay, I want 2 replicas, or the client wants 2 replicas, so I will create 2 pods, and then also look that they run. And if you delete one, or some gets killed, he will look that he gets back to the desired state and recreates these pods. And this is the desired state concept, and this is done with YAML files, right, or JSON. But normally you use YAML files, and you define them how you want these states to be. The problem with that they get hard to read really fast, because you have many of these files and they get longer and longer because they are a little bit low level, but that's also mainly the case because it's just so powerful and you can configure so many things. And what sometimes happened, and I saw, is then that just some people copy-paste these resources, right? They already have one deployment, then they want something other deployed. They will just copy-paste and then change the things that they wanted to have changed for the new deployment. And then you don't know, are some changes really intended, or are they just copy-pasted? Because you don't have an abstraction level that always fits. And also the rollback can get a little bit hard. When you have many resources, you don't know if you want to go back. Maybe you have even the manifest in Git, right? You can go back, but then you don't know, well, do I just do a kubectl apply again, or do I also need to delete some resources because they're not there anymore? And here comes Helm into play. They will solve the problem for you. Helm, right, is an analogy to boats and ships and sea again, like many Helm Kubernetes products. It's a Helm is the one that sails the boat. And yeah, I think it's a really good analogy. With that, you steer the ship of Kubernetes. So Helm is also in the CNCF. It's a graduate project of the CNCF, and it uses packages called charts to deploy these resources. So as you would do with apt-get, you do the same with Helm for your cluster. And what does it do at the end? At the end, it does nothing more than create, update, and delete resources on the cluster with kubectl apply and delete, or similar to that. Now, I talked about chart. How do chart look like? So chart is like a folder, and in the folder, you have always a chart YAML. These are the metadata in there that describe the name, version, and so on, like the basic stuff. Then you have a templates folder. In there are the templates that then get rendered, and with that, you then have the Kubernetes manifest at the end. To configure stuff in the templates, you use the values to say, hey, how should it be configured? And this is how a template looks like. So these are the manifests that you know from Kubernetes, but with the Go template syntax in it. So inside these curly brackets, you see, for example, here an include or just a value that will then be added. You can also have if-else statement, loops, and so on. It's quite powerful what you can do in there. Because it's more or less the whole Go language at the end that you can use. You can also add more functions in there if you have special cases that you want to cover. Now, for people that used Helm before, maybe a little bit longer ago, and thought, it's not really what you think wanted, so be careful to not think of Helm with Helm version 2. Now we are in Helm version 3, and they have significantly changed the architecture. In Helm 2, you had a trailer. This is in the Kubernetes cluster, and your Helm CLI on your computer interacted always with a trailer, a server part of Helm. And this then talked to the API server in Kubernetes and applied these resources. With Helm version 3, they removed this trailer part, and now it's a client-only application. So for once, it's really simpler, right? You don't have to deploy anything before you can use Helm. Everybody can just use it as a user. And second, it removed the security nightmare of Triller. Because with Triller, you had one component that was able to create namespaces, create any deployments it wanted in any namespace that you ever want something to deploy, and also to monitor all these things, delete it, right? And with Helm 3, it's really just a client, so you give the access with RBAC to the developers really just what they need in the namespaces that they need, and then everybody can just deploy what they want. The same, of course, with DevOps approach if you then have some services that will deploy it for them. Okay, but that was enough theory. Now let's try it out. I want to go to you through a sample Nginx deployment and show how you can do a really simple Helm deployment. All samples that I will show will be in a repo at the end that I share with you if you want to try it out for yourself. So if we want now an Nginx deployment, how do we do that? It's really simple. So first, we just have to find the chart that fits our case. And second, we install it. To find charts, you can use the artifact hub. Here you see a screenshot of the Nginx sample chart that I selected for this demo. So you see a description, you see the template, you see how to install it, and so on. And then you just install it. Helm install, then you say here hello world, that's the release name, and then you say give up the path to it. And that's it. Then you can do a port forward to see if it works, and yeah, we have our simple Nginx hello world sample already done. But that was really fast. Let's look into the detail what happened. So the first thing that we did, and there are also commands that do just parts of what we just did with install, is pulled the chart. So we can pull the chart with Helm pull and put it onto our machine. We can also just unpack it, that we get the files. And then we see it's exactly how I showed you. It's a chart with the templates in it. And then we can look into a template and we see the Go template syntax in it that will be used then to render the chart. Next, we can template it. With Helm template, we can now template the chart, so execute the Go template syntax to come out with the applicable Kubernetes manifest. And here we see now he put in the name hello world where before the placeholder was. Next, we can now install it. The install will again template it, and then it will deploy it. We see also, as before, that we have now this info screen showing how we can use it, where it exactly was deployed, how we get the port, and so on. This is a help file that you can also add to every chart, so it gets simpler for the developer that installs the chart on what to do next, what are the options with the deployment that he just deployed. Good. And then the last step is we can also look onto the cluster with kubectl and see, okay, did he really install it? Yeah, we have our service, we have our deployment, we have our pod. And what's here maybe new, if you didn't use Helm before, you can use Helm ls to then also see the Helm release. Here we see that we have our Hello World release in the revision 1. So, really short, what we did, we first downloaded it, then we templated it, then we installed it, and then we saw our release. These are like the options that you do, or you can also really simply just install it. So that was a really simple Hello World HTTP server, right? But we can do more. Here are some common use cases and really for used charts. So for example, Prometheus, Postgres, and so on. And also we have a hardware talk later. So also that is possible to install on your Kubernetes cluster with a Helm chart. Okay, great. But probably this chart will not fit your use case one-to-one, right? Probably you want to change something. And that is also really simple. With Helm, you can then also just set parameters to the end to customize the chart as you want. For that, all these template variable in it, right? And you see now there is an upgrade. It's not anymore install, because the first time you install it, and then when you want to do changes, and that's just what we do here, then we can upgrade the chart. So either we can do that with the CLI again, right? Just with set parameters, or if we get many parameters, maybe we want also to store these parameters and versionize it, we can also apply it with a file. Then when we do that, it's a good practice to first do a Helm diff to show what really will be changed. With that, we can simply show what resources and how will they change when I now upgrade the chart. This is an extra plugin. It's not in the default version, but I think it's really helpful. Then we can upgrade the chart, and then we see again with Helm ls that we now have a second revision of that chart. We can test that, right? And if we see, well, we broke our deployment, it doesn't work anymore, not much to do, we can just roll back to the previous version really simply. Okay, great. Now we use all these Helm charts for all our resources that we need, but we have also an own app, right? With the own app, it's not that simple because you don't find any charts that will fit your need. So now let's create our own chart. Creating an own chart is also really simple. You can just use Helm create and the chart name, and then you get the chart. Then you need to configure it, right? So on the right side, you see how it looks. You will need inside the template to configure what you want. Here now I just configure the config map, but probably you will do there a deployment and maybe a service and so on, what you need, and you can configure that. You can really start simple and first also just put your Kubernetes manifest just in this file, and then later on start adding these template variables to configure it. In the values, of course, then you can add the values how you want to configure it. And this helper TPL file, that's what you saw before on the nginx deployment that showed you the port, how to get the port and so on. And when we did that, and it's a really great chart, then we can also push it. Here is the Open Container Initiative format of it. That's a little bit new in Helm. Now you can just push these charts to a Helm repo, to a Docker repo, and you don't need any special registries anymore. Before, normally, and many charts still do, have special Helm repositories that also work. But now you're way simpler and faster with just using the OCI registry. Good. Now we also do that, and now we have so many apps. Do we have now a mess? Because now we have to install all these separately, right? We have to upgrade these. This can be heavy. But there is a solution. The official solution from Helm is we can do an umbrella chart. So we build one umbrella chart that covers all our charts inside. That means that we now have one release, and we can just release that chart, and inside that chart you will have then the dependencies to all other charts. This can be now, as here, remote repositories or also local repositories. This can be nice, but it can have also some problem. So one is we have always just one version. So if you change something and it will break, you have to go back to the previous state with everything together, because it's one release, you have to roll back everything together. It's also atomic. You can also implement tests in a Helm chart, and if something fails, you can't release everything. Maybe it's what you want, then that's a great fit, but maybe it isn't. Then also, the problem is you have really to look for isolation. Names are not isolated. So if two have the same name, two chart releases, this will get conflicts. And also, just be aware you have to install the subcharts first separately. And then, what about these common resources? We can't, or it's really hard, to then use sub-resources in two subcharts. So having sub-resources used in two sub-resources, right? And there it's simple, you can just push them up. Most charts give you the opportunity to not add sub-resources in addition, but you can also mostly say, I don't want them, and then you can install them separately. For example, like databases or so. Another thing that when you go to production that you will find out, right, is probably you need some environment-specific variables, for example, URLs and so on. You can also do that with Helm when you just use the multiple environment files to then override these things. So they are applied from right to left. So you can, on the right side, start with then, sorry, on the left, start with the environment specific that overrides then the other ones. But this gets more and more complicated with these Helm charts. Or the other way around. but you can find that in the sources, the right direction. But it gets more and more complicated, and I never use that with these multiple files. What's the solution here for me at least, and that's why this project exists, is helmfile. This really simplifies your life when using Helm. You can, with helmfile, it's really just, as the name intends, it's really just one file with one CLI in addition, where you can configure multiple releases. So in here, you can have multiple releases that have here in the names. And these are now real Helm releases. So with that one file, you can manage multiple Helm releases in once. So you don't need an umbrella chart, but you can keep these releases separately, and you can also roll back these separately. Also, if they fail, you can go back just with one. You don't have all or nothing solution. So the atomic level is again back to the sub chart, if we talk about the umbrella chart on top again. And the other thing is also that with that we can also have dependencies, and in behind he builds the deck. So you can really say, okay, this chart will need that to be first installed, and he will come up with the correct solution to do that. If you're happy at the end, you can just use a Helm file apply to then install everything. Then, second attribute that you see here is a namespace. So not like the umbrella chart that needs to be in one namespace. You can here, indent one file, also do things in the different namespaces. You can also add different environments also to the same file with helmfile. And I think that's way simpler. So here you can define different environments and then also do different values per environment to override. So this, here now I'm used another file, the production YAML, but you can also do that inline if you prefer. Then something that I'm used a lot of times and why I'm always switching it again back to also include helmfile is that you can use Go templating also in values. So with Helm, you just have to, inside the template folder, you can use the templating engine, but not in the values. And when you get big deployments, it's really handy to also be able to use it into the value section. For example, if you build up URLs or if you have to hash values and so on, that's really helpful because then you can also inside the values do there some templating logic, some loops and so on. And another really good point about helmfile is there is no difference between install and upgrade and subcharts adding and so on. It's really more declarative. You can always just use helmfile apply. First time, second time as well. And with that, why is that so important that it's always the same for CI/CD? Now, let's look shortly into how we can apply this to GitOps. So Helm and helmfile is all already in simple files, right, that are really good to version in Git. You can check them in to a main branch. And then if you do changes, it's really good practice, right, doing short-living feature branches. And there you can add your changes. Then you can use either Helm or helmfile, what you prefer, doing a diff to show that. Maybe also add that to a comment on the PR as you want. And then you can use lint to review if something broke, if something doesn't work with the setup or so. And if that's also fine and you have somebody that approves your changes and the pipeline runs, then you can merge it and then use either Helm upgrade or Helm apply, right? And if you would have some new subcharts or so, be aware that with Helm you would also need something, an additional command to install it. Or you just use helmfile and you always apply and it's done. If you're committed to Terraform, it's also possible to use Helm just as a provider inside Terraform, and then you can do it also there. This is also a really nice, simple way. There is also a Helm file provider, but this is not well maintained, and I can't really recommend it because of that. Good. Then to the conclusion. So I really think it's a simple, nice tool. Just give it a try. I think it makes your life really easier. I saw many teams also using self-made, some customization on Kubernetes manifest, which is just a struggle, and I think Helm can really solve these problems. Also, when you use these finished Helm charts, at many places you just use the resource as intended, right, with already defined RBAC roles for the resources and so on, which make it way nicer than just creating them on your own. And yeah, give it a try. Here's my sample repo. You can just use it also in GitHub code spaces if you want. There is one button, then you can start your GitHub code space. You don't even need more than a browser, and then you can use your Kubernetes cluster hosted by GitHub. Good. Thank you very much.